welcome to the YouTube channel me.u. Math e-learning with us, an unique experience in mathematics learning. I am Shamsuddin with you. Today we are going to discuss the first chapter of class 10 mathematics, real numbers. Let's see what are the learning objectives of this chapter. First one, to understand Euclid's division lemma, to be able to find out HCF of two given numbers using Euclid's algorithm, to be able to find HCF and LCM using prime factorization, to be able to use the formula HCF times LCM equals product of two numbers, to be able to understand fundamental theorem of arithmetic, to be able to prove the numbers like root 2, root 3, etc. are irrational numbers, to be able to tell whether the given rational number is terminating decimal or non-terminating decimal by looking at its denominator. This chapter, real numbers, is one of the easiest chapter of class 10 mathematics. You know why? Because only a few types of questions are there. So if you learn only few types of questions, you can score full mark from this chapter. Okay, now we'll see each of learning objectives one by one. Real numbers. Numbers. When did you start learning about numbers? First day of schooling? No chance, right? Even before, you might have started counting 1, 2, 3, etc. And from the lower classes, you started learning about number in every class, not only lower classes. Every class, the first chapter is about numbers. Did you notice that? In lower classes, you started the natural numbers or counting numbers, numbers like 1, 2, 3, 4, up to infinity. Then later you added 0 to natural numbers to get the set of whole numbers. Then negative numbers, that means integers, fractions, decimals, rational numbers, and in class 9 you studied about irrational numbers. The set of all these numbers is called real numbers. So real numbers is a big world of numbers, including all these things, whatever you learned till now. Together we'll say real numbers. Why the name real? Huh? Real. Real means something, the opposite of real is virtual or imaginary or unreal, maybe. So is there something unreal or imaginary or virtual in number system? Yes, there is. There is a system, imaginary number system, but it is not there in a syllabus now in class 10. If you are interested in learning math in class 11, so you will learn about imaginary numbers in class 11. Okay, now we'll learn about real numbers, all the properties of the real numbers, and rational numbers, irrational numbers, terminating, non-terminating decimals from the fractions. All these are included in this chapter. So we'll go one by one here. Okay. Now we'll move on to the first subtopic of the first chapter, real numbers. You remember in your smaller classes, while learning the division for the first time, you were verifying it, right? How you used to verify? So we'll use dividend equals divisor times quotient plus remainder. And this is the way to check whether our division is correct or not, because this relation holds for all divisions. And even in class 9, you used this one, where in the chapter polynomial, you remember, for the polynomial divisions. Okay, so from this, from all our experience, we can make a statement. Any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder R that is smaller than B. Is it correct or not? For any positive integer. So we'll check it. We'll take 4 examples and we'll check whether it is true or false. Okay, so first one, 35,6. So we'll divide this one and we'll verify. So 35 divided by 6. How many times? We know 5, 6 are 30. So it is 30 and the remainder is 5. So here the 35 is the dividend. This is the dividend, right? 35 is the dividend and 6 is the divisor and 5 is the quotient and this 5 is the remainder. Okay, so using this division we can write 30. We can make a relation between 35 and 6. We can write 35 equals divisor time, that is 6 times quotient is 5 plus remainder plus 5. So this is a relation for the 35 and 6. We'll go for the next example, 15,2. So we'll divide 15 with 2. So we know that 7 2s are 14. So remainder is 1. So we can make a relation 15 equals the divisor 2 times the quotient 7 plus the remainder 1. Right? Now we'll move for the next 20 and 5. So 20 divided by 5. How many times? We know 4 5s are 20. 4 5s are 20. Remainder is 0. So we can make a relation 20 equals divisor 5 times the quotient 4 plus the remainder 0. And the last example, 236 and 5. So we'll divide this one, 236 with 5. So in 23 we know 4 5s are 20. So we'll subtract, we'll get 3. We'll take the 6 here. So how many 5s are there? 36? We know 7 5s are 35. So 35, remainder is 1. So you can write 236 is equal to the divisor 5 times quotient 47 plus the remainder 1. So from all these examples, we can say for any positive integer a, any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder, always leaves a remainder which is less than the divisor. So you can see in the first case. So in the first case, the remainder is 5 and the divisor is 6. 5 is less than 6. In the second case, the remainder is 1 and the divisor is 2. So 1 is less than 2. The remainder is less than divisor. The third case, the remainder is 0 and the divisor is 5. 0 is less than 5. And the last case, the remainder is 1 and the divisor is 5. So 1 is less than 5. In all the cases, we got it. The remainder is less than the divisor b. So the same statement will form into different structure, and that is the theorem of this chapter. Theorem 1.1, Euclid's division lemma. Given positive integers a and b, so if two numbers are given, there exists a unique integer q and r. You can find two integers q and r unique. Why the word unique? Because if you are solving for 35 and 6, everyone will get the q as 5 and the remainder r as 5. So it will be same for all. You won't get different answer for different students. So for all the students, all the people, the answer will be same. So that is, it is unique integers. So we can write satisfying A equals BQ plus R, such that 0 less than or equal to R less than B. That means the remainder will be always greater than or equal to 0. The least value of the remainder is 0, and it can go up to a number less than the divisor. Less than B means it is not equal to B. It will be always less than the divisor. So this is the Euclid's division lemma. It is nothing but the uh, division checking only, that the rule of the division, dividend equals divisor times quotient plus remainder, but it is applicable for all the positive integers. So we can make a relation between any two positive integers using this. So this theorem is very important in number system, and in this chapter, we'll study two of the applications. One, to find the HCF of two numbers, and to verify some properties of the numbers. So these are the two applications of Euclid's division lemma in this chapter. Okay, we'll move on to that. The first application of Euclid's division lemma is to find HCF of two numbers. HCF. What is HCF? We studied in smaller classes, right? HCF, highest common factor between two numbers. So we have different method in lower class. Also we used factorization method, and right, to find, or writing all the factors. In the beginning you were writing all the factors of the numbers and identifying the highest common factor, and after that you studied to factorize the numbers and to find HCF. Here we'll use Euclid's division lemma to find the HCF of two numbers. So there is a series of procedure which is called Euclid's division algorithm. An algorithm is a well-defined procedure, a series of well-defined steps which gives a procedure for solving a type of problem. So a type of problem is there. So a fixed method, a procedure. So if it is yes, you continue. If it is no, you go this way, and like that. So yes or no. So you need to, in each step you have to verify whether this achieved yes or no. If it's yes, we'll stop. If it's no, we'll continue, like that procedure. And this in your textbook it is given, a box is given, right, is an extra information, not for the exam purpose. You can see the word algorithm came from a Persian mathematician, Muhammad bin Musa al-Khwarizmi. So he is a 9th century Persian mathematician, and he has a well-known book, Isabel al-Jabr wal-Muqabla. Okay, this is only for an information. Okay, an algorithm is a set of well-defined steps, which makes a procedure. So here we'll use this one to find HCF of two numbers. So instead of going to the steps, I will explain through example. Use Euclid's algorithm, division algorithm, to find the HCF of 4052 and 12572. Okay, so first step is identify which is the larger number. So which is the larger number? This is 12,572 is the larger number. You need to write the larger number first. So 12,576 equals, it is equal to, we'll take the second number as the divisor. So 4052 times a number. We need to fill a number here. So for that, what you need to divide. If you're dividing, you'll get the quotient as 3. So 3. So 3 times 4000. So we'll verify here, 4052 times 3. So what you'll get? 6. 3 5s are 15. 4 is 12. So 12,156. And if you're subtracting this one, you will get a remainder 420. Okay. Now, once you need to check it is a procedure, right? You need to check whether the remainder is 0 or not. The remainder is the last one. The last one is not 0. If it's not 0, what you need to do is you need to take this divisor, and the divisor will become the dividend for the next step. Okay, for the next step, our divisor is the dividend. So you will write 4052 equals, now the remainder will become the divisor. The remainder is of the previous line is the divisor of the new line. So we'll get 420 times. How many times? So you need to divide or you need to multiply. So when it goes more than 4052, you need to stop. So we'll get the number 9. So 9 times 420 is 3780. It will leave a remainder 272. Next, so it's a procedure, it's an algorithm. You need to check whether the remainder is 0. No, the remainder is not 0. You need to continue the same step. What is the step? Take the divisor of this line, take the divisor and make it as dividend for the next line. So you'll get 420 equals, take the remainder of this line and make the divisor of the new line. So it is 272 times. We need to find out which number. So if you are multiplying, it should be less than 420. So we know that it is 1, because if it 2 times means it is more than 500. And it will leave a remainder 148. Since the remainder is not 0, we need to proceed again. Again, we'll continue the same step. So the step is, we'll take the divisor to make it dividend for the next line. So this is 272 equals, we'll take the remainder of the previous line, that is 148, as the divisor of the new line. 148 times, so 148 times 2 is more than 200, nearly 300, right? About 296. So it is more than 272, so you can write only 1 here, plus it will leave a remainder 124. Okay, again we'll check, is the remainder 0? No, the remainder is not 0. So we'll continue. So we'll take 148 here, the divisor of the previous one, 148, equals the remainder 124 times, you need to find out the number. So it is 1 here, because 1 times 124 less than 148, 2 times 124 is greater than 148, which will leave a remainder 24. Again we are checking, is the remainder 0? No, the remainder is not 0. So we'll continue. Again the same step, same procedure. We'll take the previous divisor as the new dividend. So it is 124 equals the previous remainder as new divisor. 24 times, which number? 24 times 5, 120, right? So it is 124, so you can write 5 here. Leaves a remainder 4. Again we'll go and check, is the remainder 0? No, the remainder is not 0. So we'll proceed with the same step. We'll take the 24 as the new dividend. 24 equals the remainder as the new divisor, that is 4 times, we know 4 times 6 is 24. That means it will leave a remainder 0. Now we'll check, the remainder is 0. Yes, the remainder is 0. If the remainder is 0, okay, we'll stop. The procedure is stopped. So when we'll stop the procedure? once you get the remainder 0. Once you get the remainder 0, the previous remainder, that is 4. The previous remainder 4 is the HCF of these two numbers. Is it clear? The previous remainder 4 is the HCF of the numbers 4052 and 12576. So you need to continue the same procedure by checking the remainder is 0 or not. If the remainder is 0, we'll stop there and we'll go back to the previous step to get the remainder of the previous step, and that remainder is the HCF of two numbers. Is it clear? Okay, and you must take a notebook and do along with it. Okay, you take a pause. You can press for pause, and either you take a note of this one, or you, without looking at this, you do it again. You repeat these steps again. Okay, I'll do one more example. Use Euclid's algorithm to find the HCF of 38,220 and 196. What is the first step? What is the first step? First step is to check which is the bigger number of from the given. So the biggest number is 38,220. So we'll write 38,220. 38,220 equals 196 times a number plus a remainder, right? We need to fill it. So for that we need to check. We need to divide 38,220 divided by 196. After dividing, we'll get here the quotient is 195, because 196 times 195 is 38,220, which leaves a remainder 0. The first step itself we got the remainder 0, means there is no previous line, right? So the second number is the HCF. So the second number is the HCF of the, actually here in the previous and the previous uh, remainder means the divisor, right? The divisor is the previous remainder. So here there is no previous line. So the divisor is the HCF of the given numbers. So what is HCF? HCF is 196. Okay. One more example. Now in this question, I will explain you how to find HCF of three numbers using Euclid's division algorithm. So for this, the first step is to select two numbers, two smaller numbers. Okay, select two smaller numbers. Which are the two smaller numbers? 18 and 30. Out of that, 30 is the bigger number. So first we'll do for these two numbers, 18 and 30. And in that 18 and 30, 30 is the bigger number. So we'll write 30 equals 18 times dash plus dash, right? So we need to find out. So 18 times 2 is more than 30. So it will be 1 here. And we know the remainder is 12. Is that remainder 0? No, the remainder is not 0. So we need to continue. So we'll take this 18 equals 12 times a number, 12 times 1, right? 12 times 1 plus it will leave a remainder 6. The remainder is 0? No, the remainder is not 0. So we'll continue the step again. So we'll take the previous divisor as the new dividend, that is 12. 12 equals the remainder, previous remainder as a new divisor, that is 6 times 2 plus 0. So here we can see the remainder is 0. When the remainder is 0, the divisor of that line or the previous remainder, both are same, is the HCF of two numbers. Now we'll take the 6 and the third number. Okay, so 6 comma 78, the HCF of the two numbers, first two numbers, two smaller numbers with the bigger number. So in this one, we'll write 78 equals 6 times dash plus dash. So what is the number here? We know 6 times 13. 6 times 13 is 78. This will leave a remainder. This leaves a remainder 0. So when you get a remainder 0, the divisor is the HCF. So HCF of these numbers, HCF of 18, 30, 78 is 6. Is it clear now? So we'll use Euclid's division algorithm to find the HCF of two numbers or three numbers, and this is one of the important question for your examination. So because this chapter, this is one of the main topic, so you can expect a question to find HCF of two numbers using Euclid's division algorithm. And this is for today, and you have some home assay practice work, because to learn math, the only way is to do math. Without doing math, you cannot learn math. By listening or by hearing only, you cannot learn math. If you want to learn math, you must do in a paper. So you take a pen and paper, book, write all these things, and there is a practice questions. Do all the practice question. You can send the answers in the chat, and we'll reply for that. Okay. So these are the practice questions. Very simple, 3 questions. Take a book and do it now itself. Remember, to learn math, the only way is to do math. And all the answers will be displayed in the next video. And also I will reply for your chat answers. Okay, and another important thing, you must subscribe for this channel, otherwise you won't get the updates. And also press the bell icon so that you will get the notifications. Okay, thank you for watching. We'll see you in the next class.